Alrighty, we're back. So in the last video, we talked about how to send inputs to your Cartesi dApp. Now we're going to talk about how your Cartesi dApp can actually generate outputs and how you can check them, list them, or do whatever you want with them. You're really powerful in this case. Let's go back to our dApp and understand again what we did. In the last video, what we did was decoding the data, creating a payload string object with the hex to string, and just printing it on screen. Now, let's make it a hello world application of sorts, but let's make it a little different. Add a small twist to it so we can actually see that the output is different from the input. Let's make it to upper, so any sentence that the user sends, it's returned as an uppercase version of itself. This way we can see that there is some processing happening inside the handle advance. Okay, but how do we do it? Open another terminal here in VS Code so you can see everything all at once. Let's generate an output. The same way we did a hex to string, we're gonna have to have an auxiliary function, the string to hex, because everything in blockchain works through hexes. We have to convert the processed string to a hex again. The way this is going to work is I actually have to import a lib called bin-ascii2. It comes by default with Python, so you don't even have to install anything in here. But if you require to install a lib, you can just use the requirements.txt. And when you're building our application through the Docker file, there will be an install of all the libs in the requirements. So your application will be running with any dependency that you want. All right, function created, and now we can use it to generate an output. Well, first let's make the uppercase version of our string. And now to create the output, we're gonna copy this request here, because this will allow us to call the HTTP API that creates outputs for our dApp. One last thing, the data here has to be a JSON, and the format has gotta be sending a field called payload with the content of the payload. And run. Okay, since my dApp is running, I can now do a Cartesi send. Now, yes, string encoding, and I'm gonna see send. Let's see if it is converted to uppercase. The input was sent. I got the sentence inside the application, and then I created a notice and received 201 as a response. So let's check our inputs in here. And this is the input that I sent. Let's see if it is converted to uppercase. You can see it generated a notice. The notice has the content, and it's uppercase content right now. That shows that our code actually works. And you can see how you can actually make modifications to your inputs inside the handle advance function and create outputs from it. But how do I access these outputs from my front end, for example? Well, remember when we ran the application, we got many endpoints and we were using only the Explorer so far? The next one we're gonna use, it's the GraphQL Playground. The GraphQL Playground is this interface right here where I can make queries to my outputs and list them. So I'm gonna query all notices, and I'm gonna get the index of the notice, the input index, and the payload of that notice. So here you can see that I generated one output, and I can actually list it, and I can query it through the index. So as soon as I get a confirmation that my transaction was finished, I can start pulling for notices and get the content of this notice. If you want to do a hex to string, I can actually write here, and you can see that the content is the same. So it checks. There is a GraphQL API, just like there is the HTTP API, that you can query for and get the content from your notice. So let's try to send another input to see whatever will happen. Generic input, just sent, got the confirmation, created the notice for it. Gonna refresh here. Check it out. Another test of the input, and if I query the notices, I will get another notice right here. As you can see, the input index is different, so this is a great way for you to query the data in your front end whenever you want to present whatever was processed in your backend in your front end. Now, when you see this interface, you can actually see that we have input, we have notice, that it's the kind of output that I generated, we have reports, and we have vouchers. What are the differences between these three kinds of outputs right here? Let's refer to the docs. If we go to backend APIs right here, we can see what this means. A notice is a verifiable data declaration that attests to off-chain events or conditions that accompany by proof. This means you can actually do a validate notice in your Cartesi dApp contract to check if that output actually exists and it's correct and it has a proof. A report, differently from a notice, has no proof. It's just a stateless log that you use to diagnostic purposes or to inform the users of things. It's great to provide insights of the performance of the dApp, of the state of the dApp, of how its operations. There is the third one, which is the most complex one. It is the vouchers. Vouchers are a mechanism for facilitating on-chain actions initiated in the execution layer. What does that mean exactly? It means that whenever you create a voucher, you pre-sign a transaction. And then this transaction can be signed for another user and be executed through the execute voucher method that is in the Cartesi dApp contract. This means if I want to mint an NFT, I can have a smart contract with mint NFT function and call this function through a voucher. And then a user can execute this voucher to actually execute the mint function inside that dApp. For vouchers, we're probably gonna need a bigger lesson focused on only that, but let's try to create a report just like we created a notice. Let's create a function, is numeric, to check if the input is a number instead of a string. And if it is a number, we can raise a report saying, I'm not actually gonna make it to uppercase because this was not text, this was just a number that was sent. The way I'm doing this is by creating a function called isNumeric that tries to convert a string to a number. If it manages to convert, it is numeric. Otherwise, it's not a number, so it returns false. What I'm doing here, it's pretty much the same as creating a notice, but I'm creating a report. I basically change the endpoint from notice to report. And with the same structure, I send the message as a hex. The input sent was a number. So to test my code, I'm gonna once again Cartesi build and then Cartesi run. It's running. Let's check the Explorer once again, and you can see that every time I rerun my application, all my inputs go away. That's because the whole local blockchain is restarted and my application is restarted as well. It starts from scratch as if it was a completely new application and has never received an input before. We're gonna try with two different inputs, a string one and a number one to see the difference. This is a string input. Okay, I already got the confirmation right here. Now for the number, I'm gonna send 1, 2, 3, 4, and I'm gonna create a report. You'll see the confirmation right here that this was not a number. Okay, so let's see the inputs generated. This was the string one. It generated a notice. This is string input. And this is the number one. I sent 1, 2, 3, 4, and it generated the report. Input sent was a number. So you can actually treat errors with reports. This covers basically all the process of sending inputs and retrieving outputs, except vouchers. As I said, we're gonna see this in a later class. But you can actually query for reports just like you do with notices. So for notices, I have this notice generated, which the content is this is a string input. And if I'm querying reports for a good practice, so we don't lose the query, I'm going to do reports. There is no proof in the report, so there is no reason to print a proof in here. And I'm going to query my reports. This is the content of the report, which says the input sent was a number. I think that covers our interactions with inputs, sends, outputs, how to use the Explorer, how to use the GraphQL API, and how to use the HTTP API to generate the outputs. So see you next class for a little bit of understanding how the state of the machine works and how you can use inspect to read states of the machine.